Hi everybody, today we will study nuclear energy, so we will learn how nuclear power stations work. A nuclear power station is a type of thermal power station, but it doesn't burn any fuel to produce the electricity. They use the fission of uranium atoms to produce the electricity. If you remember from previous days, thermal power stations used fossil fuels to produce heat, to heat the water to produce steam, to move the turbine to produce electricity. But in nuclear power stations, we will produce heat by fissioning the uranium atoms. Before we see how a nuclear power plant works, we need to study the basic process which produces the energy in this kind of power plants, the uranium fission. First, we will go over some facts about atoms. Matter is made up of atoms. In every atom, we can find three different particles: protons and neutrons in the nucleus, and the electrons turning around the nucleus. The nuclei of some atoms, for example uranium, are unstable. This means that over a long period of time, they split naturally to form other atoms with smaller nuclei. This phenomenon is known as nuclear fission. When fission takes place, a lot of energy is released. Esto quiere decir que hay átomos, como por ejemplo los del uranio, que son inestables. Es decir, que cuando pasa un periodo de tiempo, ellos de manera natural se dividen en otros átomos más pequeños, y cuando esto ocurre, se libera una cantidad ingente de energía. During the fission in uranium, 2 or more neutrons are emitted and energy is released. Es decir, a la vez que el átomo se rompe de manera natural, también se desprenden 2 o 3 neutrones que salen a una velocidad alta despedido. If we put enough uranium together, we get a chain reaction. The neutrons released by the fission of the atoms hit the nuclei of the atoms around them and cause them to split. Look at the chain reaction. Si habéis podido ver, cuando se divide el primer átomo, se liberan 2 neutrones que golpean al siguiente átomo, de manera que se vuelven a dividir en 2 y vuelven a emitirse 2 más, 2, 4, 6, 8, de manera que se multiplica la reacción en cadena y la energía que se produce va en aumento. At the same time, during the fission, the splitting up of atoms releases high-energy particles, known as radioactivity or radiation, alpha radiation, beta radiation, and gamma radiation. This radiation is very dangerous for all living beings. So, during the uranium fission, we obtain on the one hand a very high amount of energy, but on the other hand, we obtain radioactivity. And now let's try to explain how a nuclear power plant works. The nuclear reactor and all the elements which are in contact with radioactivity are found inside the containment building. This is the containment building. This building has very thick concrete walls to prevent any radiation from escaping. And inside this building, it is the reactor. This is the nuclear reactor where fission takes place. inside the reactor we have water, always in liquid state, and these rods that are made of uranium. Putting a lot of uranium together causes a chain reaction, which releases a great deal of calorific energy. To control the chain reaction, we need some control rods. The mission of these control rods is to absorb neutrons. Para controlar la reacción en cadena necesitamos lo que se llaman barras de control. Las barras de control son barras que están hechas normalmente de boro, de cadmio o de otras aleaciones que según se insertan van a absorber los neutrones producidos en la reacción en cadena, de manera que si necesitamos más calor las vamos a retirar y si necesitamos controlar más la reacción en cadena las vamos a insertar para ir absorbiendo neutrones que sobran. The water inside the reactor is used to cool the reactor and to carry the heat generated outside. The temperature of this water is around 300 degrees. But it isn't steam. It is water with a very high pressure, pumped by this pump, and this is the primary circuit in the nuclear power station. So when the water exits the reactor, the temperature is very high. When the water leaves the reactor, it enters the steam generator. In the steam generator, part of the calorific energy is transferred to water in another circuit. So here there is another circuit of water, the secondary circuit, that is separated from the primary circuit. The water in this secondary circuit turns into steam when it receives the heat from the primary circuit, and then this steam travels at high speed through pipes to the turbine and makes it to turn. The generator is joined to the turbine and it turns, creating electricity. The steam that comes out the turbine doesn't have kinetic energy, so it has to be cooled and turned to water. It happens in the condenser. The condenser has a pipe with cold water running through it to cool the steam. And at the end we have liquid water that comes into the steam generator again, and after that again to the turbine, again water, and this is the secondary circuit. Este circuito, si recordáis, es exactamente igual al que hay en todas las centrales térmicas. Un sitio donde tenemos un calor que es transferido al agua para emitir vapor, vapor a presión contra los alames de la turbina está unida a un generador que genera la corriente. Este vapor necesita condensarse para volver al estado líquido y poder moverse. Para que se condense necesitamos otro circuito que lleve agua fría para que ese vapor se convierta en agua de mar. The condenser needs cold water to work. Water is often taken from a river or from the sea, and sometimes a cooling tower, like this, is used, as you can see in this animated picture. A current of cold air flows through the tower, entering from the bottom and leaving through the top. This air cools the water in the condenser, causing it fall like it would be from a shower. Si veis, lo que hay en este sistema es agua fría que entra por aquí al pasar por el condensador se va calentando y al llegar aquí lo que hacemos es dejarla caerse en pequeñas gotitas y una corriente de agua que de aire, que las va a refrescar según sube hacia arriba, de manera que cuando caen y se recogen aquí abajo ya estarán bastante más frías. The end result of this process is that the heat made by the nuclear fission is transformed into electricity in the generator. And as in all electrical power stations, the voltage from the current produced is raised and transferred to the power grid. If you remember, after every power station, we always have a transformer that raises the voltage from the current to be transported. Como podéis ver, lo que se produce aquí, este humo blanco que hay en las torres de refrigeración, es simplemente vapor de agua de este circuito terciario, que no es en absoluto contaminante, simplemente vapor de agua procedente de enfriar este agua que va a enfriar a su vez al circuito secundario. The main problem with the nuclear power plants is that when the fuel is spent, it becomes very dangerous radioactive waste, which has to be treated very carefully and has to be stored for thousands of years until it stops being radioactive. The energy produced in nuclear power plants has some advantages. For example, nuclear power plants do not release contaminating gases into the atmosphere, which means that they don't contribute to the greenhouse effect. If you remember, the only gas produced is steam, water steam, that it isn't contaminating. And they are very powerful plants and very stable, so they can produce a very high amount of energy, electricity in this case. Disadvantages about this type of plants. If there was a nuclear accident, the results could be catastrophic. On the other hand, radioactive waste is generated and is dangerous for thousands of years. They are very expensive plants to build, and it takes many years to build a nuclear power plant. So this is all for today. Thank you for your attention and see you tomorrow in class.